How to find domain and range of rational function. What is a rational function? A rational function is any function that can be written as function of x equal to p of x over q of x, where p of x and q of x are polynomials, and q of x is not equal to 0 because division by 0 is undefined. Steps to find the domain. Find all values that make the denominator 0. Solve q of x equal to 0. Exclude those values from the domain. Steps to find the range. We want to use algebraic method in order to find the range. And the first thing you have to do is to simplify the function if possible. Function of x equal to p of x over q of x. Replace function of x with y. So if we replace this one with y, we are going to have y equal to p of x over q of x. Multiply both sides by the denominator. If we multiply both sides by this denominator, we are going to have y q of x equal to p q of x. After that, rearrange the equation trying to solve for x in terms of y, which gives you an equation like x equal to some expression in y. Determine for which values of y these equations has real solutions. Exclude those y values. All other values of y are the range. Let us find the domain and the range of this example. Function of x equal to 1 over x. The domain. Let us find the domain first. In order to find the domain, equate x to 0. X equal to 0. Since the function will be undefined when x is equal to 0, so the domain is all real numbers except 0. So our domain will be negative comma 0 union 0 positive infinity. Function of x equal to 1 over x. Let us replace function of x with y. The equation will become y equal to 1 over x. If we multiply both sides by x, we are going to have xy equal to 1, and divide both sides by y. X equal to 1 over y. Since the equations will be undefined for y equal to 0, the range is all real numbers except 0. So our range is negative infinity comma 0 union 0 comma positive infinity. Let us find the domain and the range of this function. Function of x equal to x all over x plus 2. Domain. Now equate the denominator to 0. x plus 2 equal to 0. Add minus 2 to both sides. X plus 2 plus minus 2 equal to minus 2. This will cancel this. X equal to minus 2. Since the function will be undefined when x is equal to minus 2, so the domain is all real number except minus 2. D negative infinity comma minus 2 union negative 2 comma positive infinity. Range function of x equal to x over x plus 2. Replace function of x with y equal to x over x plus 2. Cross multiply. We are going to have y bracket x plus 2 close bracket equal to x. Open the bracket. Yx plus 2y equal to x. Let us rearrange the equation. If we rearrange the equation, we are going to have yx minus x equal to minus 2y. Let us factor the left hand side. We are going to have x y minus 1 equal to minus 2y. Divide both sides by y minus 1. X equal to minus 2y all over y minus 1. Equate the denominator to 0. Y minus 1 equal to 0. Add 1 to both sides. Y minus 1 plus 1 equal to 1. Minus 1 cancel minus 1. Y equal to 1. Since the equation will be undefined when y equal to 1, so the range is all real number except 1. Our range is negative infinity comma 1 union 1 positive infinity. This is our range. We want to find the domain and the range of this function. First, let us find the domain. And for us to find the domain, let us equate the denominator to 0. X squared minus 4x plus 3 equal to 0. And the factor form of this expression is x minus 1 x minus 3 equal to 0. X minus 1 equal to 0 or x minus 3 equal to 0. X equal to 1 or x equal to 3. Now the function will be undefined when x is equal to 1 and 3. So the domain is all real number except 1 and 3. Our domain, this is our domain. Now let us find the range. Range, let us rewrite the function. Function of x equal to x squared minus x minus 6 all over. Let us put the factor form in the denominator. X minus 1 x minus 3. Let us also write the factor form of the numerator. X squared minus x minus 6 equal to x minus 3 and x plus 2. So our function will be equal to x minus 3 x plus 2 all over x minus 1 x minus 3, and x minus 3 cancel x minus 3. So it means that at this point, at x is equal to 3, we have a O in the equation. So x minus 3, x minus 3 cancel. So the equation is going to be x plus 2 all over x minus 1. And our x is now equal to 1 and 3, because at this point the function is undefined. Let us replace function of x with y. So y equal to x plus 2 over x minus 1. X is now equal to 1 comma 3, and this is our simplified form. And the next thing that we have to do, let us cross multiply y bracket x minus 1 equal to x plus 2. Let us expand the bracket. Yx minus y equal to x plus 2. Yx, let us bring this x to the left hand side, minus x equal to, and let us bring y to the right hand side, 2 plus y. And let us factor out x from this. So x bracket y minus 1 equal to 2 plus y. And divide both sides by y minus 1. X equal to 2 plus y all over y minus 1. If our y is equal to 1, this will be undefined. So our y cannot be 1. And also at x equal to 3, there is a O in the equation. So let us use this simplified form to find the corresponding value of y at that point. Y equal to x plus 2 all over x minus 1. Let us substitute 3 into this equation. Y equal to 3 plus 2 all over 3 minus 1, which is going to give us 5 over 2. So our range is all real numbers except 1 and 5 over 2. Range negative infinity comma 1 union 1 comma 5 over 2 union 5 over 2 comma infinity. This is our range. We want to find the domain and the range of this rational function. In order to find the domain, let us equate the denominator to 0. That means x squared minus 1 equal to 0. Add 1 to the both sides. X squared equal to 1. Square root both sides. X equal to plus or minus root 1, and x equal to plus or minus 1. So our domain is all real number except 1 and minus 1. Negative infinity comma minus 1 union minus 1 comma 1 union 1 comma positive infinity. That is our domain. X squared over x squared minus 1. We want to find the range. Let us replace x squared with y. Y equal to x squared all over x squared minus 1. Cross multiply y bracket x squared minus 1 equal to x squared. Clear the brackets. Y x squared minus y equal to x squared. Let us bring x squared to the left hand side. Y x squared minus x squared equal to, and let us bring minus y to the right hand side, and the sign will change to positive y. Factor out x squared from the left hand side. X squared bracket y minus 1 equal to 1. Divide both sides by y minus 1. X squared equal to y over y minus 1. Use the fact that x squared will be always greater than or equal to 0. Since x squared is always non-negative, so this expression also will be greater than or equal to 0. Y over y minus 1 is greater than or equal to 0. Solve the inequality. And we solve a rational inequality by finding the critical point where the expression is 0 or undefined. This expression is 0 when y equal to 0. So our first critical point is y equal to 0. And it is undefined when y equal to 1. So our second critical point is y equal to 1. Now, if we substitute y equal to 0 into the inequality holds true. That means that 0 is inclusive in our range. And also, if we substitute y equal to 1 into the inequality, it will be undefined. So y equal to 1 is not inclusive. Let us use line test to determine the interval that satisfies the inequality. Our critical point is 0 and 1. Our interval negative infinity is 0 square bracket. We use square bracket because 0 is inclusive. This interval from 0 to 1 is 0, 1. We use curve bracket because 1 is not inclusive. 1, positive infinity. So what we want to do is that we want to pick number between this interval and check if it holds true. Let us pick minus 1 and substitute it into this inequality and see if it holds true. Minus 1 all over minus 1 minus 1 is greater than or equal to 0. Minus 1 all over minus 2 is greater than or equal to 0. 1 all over 2 is greater than or equal to 0. This inequality holds true. So this interval is included. Let us insert number between 0 and 1 into this inequality to see that if it holds true. And let us insert 0.5. 0.5 all over 0.5 minus 1 is greater than or equal to 0. 0.5 over minus 0.5 is greater than or equal to 0. And 0.5 divided by minus 0.5 is minus 1 is greater than or equal to 0. And minus 1 does not greater than or equal to 0. So this interval is not inclusive. And let us check with another number between 1 and infinity. And let us pick 2. That means 2 all over 2 minus 1 is greater than or equal to 0. 2 over 1 is greater than or equal to 0. 2 is greater than or equal to 0. This is true. So this interval also is part of our range. So our range will be negative infinity, comma 0, union 1, comma infinity. That is our range. We want to find the domain and the range of this fractional function. The denominator x squared plus 1 is always positive and never is 0, because there's no number that we can insert into this denominator that will actually give us 0. So the domain is all real numbers. Our domain negative infinity, comma infinity. Now we want to find the range, and let us replace function of x with y. So we are going to have y equal to x plus 2 over x squared plus 1. Let us cross multiply. If we cross multiply, we are going to have y bracket x squared plus 1 equal to x plus 2. And let us clear the bracket. We are going to have y x squared plus y equal to x plus 2. And y x squared minus x, because if you bring this x to the left hand side, it will change to negative, plus y minus 2 equal to 0. This is a quadratic equation in x, just like yx squared minus x plus bracket y minus 2 equal to 0. To ensure y is in the range, this equation must have real solutions. So the discriminant must be greater than or equal to 0. The general quadratic form is ax squared plus bx plus c equal to 0. By comparing these two equations together, we can see that our a equal to y, our b equal to minus 1, and our c equal to y minus 2. And discriminant which normally denoted by d equal to b squared minus 4ac. and this discriminant must be greater than or equal to 0. That means b squared minus 4ac must be greater than or equal to 0. Now let us substitute our value into this equation. Our value of a, our b, and our c. So we are going to have minus 1 square minus 4 multiplied by our a is y multiplied by y minus 2 is greater than or equal to 0. This one will give us 1 minus 4y bracket y minus 2 is greater than or equal to 0. 1 minus 4y bracket y minus 2 is greater than or equal to 0. 1 minus, if you clear the bracket, 4y squared plus 8y is greater than or equal to 0. Minus 4y squared plus 8y plus 1 is greater than or equal to 0. Solve the inequality. Multiply through by minus 1 and flip the inequality sign. That means we are going to have 4y squared minus 8y minus 1 less than or equal to 0. Let us find the root of the quadratic by using quadratic formula. And our quadratic formula, don't forget our quadratic formula is y equal to minus b plus or minus root b squared minus 4ac all over 2a. And if you compare this quadratic with a general quadratic form, our a is going to be 4, our b is going to be minus 8, and our c is going to be minus 1. Now let us substitute these values into this equation. Y equal to minus bracket minus 8 plus or minus roots minus 8 square minus 4 multiplied by 4 multiplied by minus 1 all over 2 multiplied by 4. Y equal to 8 plus or minus root 64 plus 16 all over 8. Y equal to 8 plus or minus root 80 all over 8. Y equal to 8 plus or minus 4 root 5 all over 8. We can factor 4 out of this expression. Y equal to 4 bracket 2 plus or minus root 5 all over 8. 4 here we have 2, 4 here 1. So y equal to 2 plus or minus root 5 all over 2. and y equal to 2 all over 2 plus or minus root 5 all over 2. This is still the same thing as this. So y equal to 1 plus or minus root 5 all over 2. That's our root of our quadratic equation. Let me rewrite our quadratic inequality, which is 4y squared minus 8y minus 1 less than or equal to 0. y1 equal to 1 plus root 5 all over 2 and y2 equal to 1 minus root 5 all over 2. This root will definitely be inclusive because these are the roots of this quadratic equation. Now let us use line test to determine the interval that satisfy the inequality. Let us draw horizontal line. Let us say here we have 1 minus root 5 over 2 is 0. Let us put 0 and let us shade it because it is inclusive. Here too, let us put 0. Let us shade it because it is inclusive. And let us write here 1 plus root 5 over 2. This region from here to here will be, we use square brackets because that endpoint is inclusive. 1 plus root 5 over 2 to positive infinity. This interval, the endpoints are this and this, so they are inclusive. We use square bracket too. 1 minus root 5 all over 2, comma 1 plus root 5 all over 2. This region also will be 1 minus root 5 all over 2 negative infinity. So let us pick a test point in each interval and test which one holds true. Let us pick -1 and -1 fall within this region, and let us substitute it into this inequality. So we are going to have 4 bracket -1 square minus 8 times -1 is less than or equal to 0. -1 times -1 will give us 1. So it will be 4 plus 8 minus 1 less than or equal to 0. 4 plus 8 will give us 12 minus 1, 11 less than or equal to 0. 11 is not less than or equal to 0. So this interval is excluded. Let us pick value within this interval. For example, let us pick 0 and check whether it holds true. 4 multiplied by 0 squared minus 8 multiplied by 0 minus 1 is less than or equal to 0. This one will give us 0 minus 0 minus 1 is less than or equal to 0. minus 1 is less than or equal to 0. This is true. So this interval, we choose it. Let us pick one number here too. And let us pick 3. If we pick 3, we have 4 multiplied by 3 square minus 8 multiplied by 3 minus 1 is less than or equal to 0. 4 multiplied by 9 minus 8 multiplied by 3 minus 1 is less than or equal to 0. 4 times 9 is 36 minus 8 times 3 is 24 minus 1 is less than or equal to 0. And our answer is 11 is less than or equal to 0. This is not true. That means we exclude this interval. Our range 1 minus root 5 over 2, 1 plus root 5 over 2